These are silicon carbide grinding media balls. Sintered ceramic spheres with Vickers hardness above 22 gigapascals, second only to diamond. The grinding media that handles the materials too hard for everything else, including the hardest industrial alloy on the market, tungsten carbide. Two properties define the silicon carbide grinding ball. Vickers hardness above 22 gigapascals, equivalent to Mohs 9.2 to 9.5, second only to diamond among industrial materials. And complete absence of metal, no iron, no chromium, no zirconium that can transfer into the powder being milled. The combination is what makes silicon carbide unique. Extreme hardness that resists abrasion from the hardest powders, with chemical inertness that preserves the milled material's composition. Wear rate stays between 0.01 and 0.03% per 24-hour duty cycle, low enough that even a 20-hour milling campaign produces measurable but trace-level media loss. Density runs at 3.05 to 3.15 grams per cubic centimeter, about 60% lighter than steel, which reduces mill power draw without sacrificing the impact energy needed to fracture hard particles. And the geometry holds through any thermal excursion the mill produces, with operating temperatures rated up to 1650 degrees Celsius. Standard diameters run from 3 mm up to 25 mm. Small balls handle final fine milling where target particle size approaches the submicron range. Mid-range balls handle primary mixing and homogenization. Larger balls deagglomerate coarse raw feed. Two sintering grades are available. Fully sintered alpha silicon carbide for highest purity hard alloy and semiconductor work, and reaction-bonded silicon carbide for cost-sensitive applications where some free silicon is acceptable. In cemented carbide production, milling tungsten carbide and cobalt powders to submicron particle size for cutting tools, drill bits, and wear parts, three things drive the procurement decision. First, hardness gap. Tungsten carbide itself ranks at Mohs 9. Alumina balls round off and lose milling efficiency within hours. Zirconia balls wear and contaminate the alloy with zirconia particles. Only sintered alpha silicon carbide at Mohs 9.5 actually fractures tungsten carbide cleanly. Second, contamination control. Hard alloy specifications routinely forbid more than 0.05% foreign oxides in the final tungsten carbide and cobalt composition. Sintered silicon carbide contributes zero metal, preserving the precise binder ratio that defines the tool grade. Third, the sintering grade. Reaction-bonded silicon carbide contains free silicon that contaminates the alloy. Sintered alpha silicon carbide is fully dense and uniform, the specified grade for hard alloy work.